Next, we want to calculate the limit of ln of n over n as n approaches infinity. Again, we can't directly apply L'Hopital's rule since ln of n over n, those aren't functions. So we'll just say, hey, let's take a look at the limit as x approaches infinity of the ln of x over x. Now we have continuous functions here, which are differentiable, of course, and we've got the ln of x as x goes to infinity is infinity over x is infinity, so we can apply L'Hopital's rule. Just a reminder, we can only apply L'Hopital's rule of the indeterminate types of infinity over infinity or 0 over 0, and when, of course, you've got differentiable functions here. So applying L'Hopital's rule gives us 1 over x, which is x to the negative 1, divided by 1. So if we have this, that means we have the limit as x approaches infinity of 1 over x, and this limit is, in fact, 0. So since this limit is 0, then this limit is also 0. And so it converges. Next, we've got this a sub n equals negative 1 to the nth power, and we want to know if that is convergent or divergent. You really don't have to do much to see what's going on here. This is alternating between positive, I guess it starts at negative 1, between negative 1 and positive 1. So does that converge? And the answer is no, it does not converge because it's alternating between positive 1 and negative 1. Do we know of any other type of perhaps function which does this sort of thing? Well, we know that like the sine of x would do something similar, and we would say that limit as x approaches infinity is oscillating, and then this one would be oscillating between positive 1 and negative 1. So it does not exist. Next one, evaluate the limit if it exists. This one we can use the theorem that we saw previously that says if we can take the absolute value of a sub n, and if it converges, to 0, then the alternating sequence would also converge to 0. Why do we expect this to converge to 0? Because it's a number on the top, a constant on the top divided by n. N is getting larger. The top doesn't get any larger than positive 1. So we expect that to approach 0 as well. So here we go. The limit as n approaches infinity of the absolute value of negative 1 to the n over n. Now, the denominator is positive already. The numerator, we take the absolute value of positive 1 or negative 1 is just 1. So does this limit converge? Yes, it converges to 0. So this one would also converge, and it would be 0 as well. We've got a theorem that says if the limit of a sub n as n approaches infinity equals L, and the function f is continuous at L, then the limit of f of a of n as n approaches infinity is f of L. So what does that mean for us? We saw something like this when we were dealing with functions. What that means is if everything works nicely, we can bring the limit inside of the function. So, question is, what's happening as n approaches infinity? Pi over n is approaching 0. Sine function is continuous at 0, so this would be the same as writing the sine of the limit as n approaches infinity of pi over n. That's going to 0, and then the sine of 0 is 0.